Alright, hello boys and girls. Welcome to Homeschool Academy. This is week number 10 of 4th grade science and technology. And today we're going to be talking about energy and power. Okay, energy and power. Uh, we may not be able to, yeah, we're going to talk about both concepts today, energy and power. So, non-scientists just think energy is the same thing as power. But you're learning about technical concepts in science right now, you're going to understand that energy is actually a little bit different, technically different from power, even though both may be related in some fashion, but you are going to know technically what energy is, the different forms of energy. We're going to be talking about the law of conservation of energy as well, and we're going to understand what power is and differentiate it from energy. So what is energy? Energy is the ability to do a particular work. And I want you to note that really well. So the ability, it is the ability to do work. Okay, that's what energy is. So if you have the capacity, for example, to jump around, it's because you got energy inside your body. And that energy comes from food, it comes from working out, it comes from certain chemical processes that go on in your body. That is called energy. It is the ability to do work. But there are different forms of works that we need to do, and as a consequence of that, there are going to be different forms of energies that we require. So for example, if you need to do mechanical work, you will require mechanical energy. If you need to do electrical work, you are going to require electrical energy. We're going to talk about different forms of energy from that standpoint. Another thing I like for you guys to notate here is the units of measurement. So how do you say how much energy does a toddler have compared to a teenager? How do you measure that energy? Well, you want to say maybe a toddler has like 26 joules of energy in his body. But then a teenager is going to have maybe like 45 joules of energy in his body. Well, there's got to be a unit to measure the amount of energy you have, right? We call that unit joules, or just J, for example. And we are going to be using that as we get to advanced studies of science and physics, potentially. All right. What about this critical law of conservation of energy, or the first law of thermodynamics? Okay, it's just a critical law that states that energy cannot be created or destroyed. In other words, energy can only be converted from one form to another. Okay. And that's true. So for example, if you have a book on a shelf, the book has what we call potential energy, which is a form of mechanical energy. If the book were to slide off the shelf, the motion created has the ability to do kinetic work, which is another form of energy. So potential energy didn't get destroyed. It just got converted to another form of energy that we can call kinetic energy or kinetic energy. So energy was not destroyed, it was simply converted from one form to another. So that leads us to the next question. What are the different forms of energy? Well, different forms of energy will start from solar energy, which is derived from the sun, chemical energy, which is derived from plants, which is the ability to do certain chemical works, mechanical energy, which pertains to static or motion related works. Okay, so that's mechanical energy. Mechanical energy gives you the ability to move. Okay, we call that kinetic energy, or the ability to stay seated. We call that potential energy. All right, so potential energy pertains to static objects, and kinetic energy refers to moving objects. What about thermal energy or heat energy? Well, that is the energy contained in heat. Okay, heat can do certain forms of works that mechanical energy potentially cannot do. Heat, for example, can turn water to steam. Well, that is some kind of work that no matter how you try to beat on that water, I am commanding you to become steam. It's not going to turn into steam. It can't do that work. What's going to do that work for you? Heat energy. What about electrical energy? Electrical energy is going to be the ability to perform electrical work, like electricity. Okay, if you yell and shout at your bulb, you say, "Bulb, shine for me. Bulb, I command you to shine for me." You push your bulb, you try to rub its head. It's not going to shine for you because potential energy cannot do the work of shining. All right, what's going to do the work for you? It's electrical energy. So when you get electricity to start flowing inside your bulb, all of a sudden your bulb is going to become shining and it's going to start to glow for you. What about nuclear energy? Nuclear energy refers to subatomic particles and energy that comes from subatomic particles. All right, what is power then? Power is the amount of energy transferred per unit time. The unit of power is watts, and it is equivalent to joules per second. So, you know that I said before that energy and power are not necessarily the same thing. All right. So power, P, is going to be equivalent to energy divided by a unit of time. So if you wanted to say how much power does a toddler have when the toddler has 26 joules of energy in her body to move a box 1 inch, is going to take him 5 seconds to do that. Well, how much power does he have? And he has 26 joules of energy. Well, or let's say 25 joules of energy. Let's say 25 joules of energy. And it's going to take that toddler 5 seconds to move 25 joules of energy 1 unit of time. Well, how much power does he have? Well, that's going to be 25, guess what, divided by 5, which is going to be 5 joules per second. Now, that's going to be the power that the toddler has. Okay, so even though the toddler has 25 joules of energy in their body, they only have 5 joules per second of power. Okay, so technically power is going to be different from energy because it is energy divided by time. All right, so we're going to be talking about those kind of concepts a little bit more as you study on with us. All right, so today we talked about energy and power. What is energy? Simply ability to do work. It is measured in joules, different forms of energy: solar, chemical, mechanical, potential, kinetic, thermal, electrical, and nuclear energy. What is power? The amount of energy transferred per unit time, which is joules per second, or watts in terms of electrical energy. Okay, so please go ahead and turn to page number 21 and answer a few questions over there to retain this content a little bit better. I want to thank you, boys and girls, for joining me today. Remember, God cares about you, and so do we. Until next time, bye-bye.
I'll be your hero's buddy, and as you study with heroes born, I will be your friend. So don't you